as kind of Shrey was hinting at before, we've been working quite a bit in trying to improve our internal developer tooling and the situation around that. And we're pretty far away from good today, but this is actually way more achievable than you might think as well. But again, as was hinted at earlier, to get to these kind of figures, we have to not just look at our developer tooling and our infrastructure, but the code base itself and how it impacts these things based on the interactions between those bits of infrastructure. And so that has required us making changes to our code base and impacting that in a bunch of different ways. Unfortunately, sometimes that upsets our devs because we go and change something that seems to fly in the face of what a lot of people think of as traditionally good code-based practices. So I know most of you here today probably aren't in a code base as big as ours, so this will mainly be a, wow, that's interesting, hope I never have to deal with that shit. But as well, maybe you'll kind of understand that literally everything in life and in engineering has trade-offs. And sometimes at a larger scale, these trade-offs differ and change the kind of behaviors that you'll have. Now, this is a introduce gray into an otherwise black and white kind of mindset. I'm not actually telling you these things are hard, bad, and never ever do them again. We still allow our devs to do them in many instances. Or it's more about understanding what could go wrong and why you might want to do something slightly differently. So before I get into those habits themselves, probably a good idea to kind of quantify what I mean by scale. I think you already got a bit of a taste of it, but just so you know, again, Jira frontend, 14 million lines of code, about 500,000 files, 5,000 packages. And that doesn't include our platform dependencies like our nav, our design system, editor, auth, all that kind of stuff. This is quite big. It's actually a third the size of the Linux kernel. Quite a lot bigger than a lot of stuff out there as well. But even more importantly than that is our rate of change. As Shrey hinted at, about 1,200 PRs every single week. That actually dwarfs most other rates of change for those same things. And that's not even a fair comparison because I'm comparing commits to PRs there. This is because we have about 600 unique engineers contributing into that code base every single month. And over broader timescales, that's get even more ridiculous. For our backend monolith, which has very similar performance profiles to this, they get about 2,000 unique engineers in a 6-month time span. So just picture how many people that really is and the kind of problems that that might create when you're trying to coordinate a code base. So that's what I mean when I'm talking about scale. Although hopefully a few of you are eagle-eyed and notice that text is a little bit bigger than last time you saw it. Because another really important dimension of scale is it doesn't stay static. It keeps growing. That is exactly double the size of the text last time because the code base doubles every 2 years like clockwork. So when you have exponential growth, it doesn't take too long to go from something quite normal to something a little bit silly to something downright ridiculous. And I know most of you are in fairly small code bases these days or in different situations to us, but especially with AI tools and other things that allow us to pump out code really quickly, it won't take too long before a lot of you end up in this situation and go, how the hell did I get here? So now you understand what I mean by scale. But shouldn't good code be good code no matter where you write it? Well, not exactly. And the best way to visualize this is with an analogy. So let's say that you commute to the office. This is Atlassian's brand new eyesore that's getting built down by Central. Let's say you carpool. So you drive along, you pick up Mr. Rogers, Dolly, and Keanu and head into the office, and everybody is happy. Except Keanu. Keanu's a little sad. Keanu is sad because he actually doesn't live on that main road there. He lives a street back, which means most days he needs to walk down to the main road where you pull in and pick him up. It's a little inconvenient, but probably okay, except sometimes it's raining, or sometimes he's got to carry a lot of stuff, and so it becomes a little bit unmanageable. In this situation, solving Keanu's problem is really easy. You can just cut through a couple of back roads. It may take you a little bit longer, but sad Keanu is happy Keanu again. In this instance, there were consequences to this choice, but they were so unbelievably negligible, you might not have even thought about them, right? Mainly what you were thinking was, Keanu is happy again. Fantastic. So this is what it's kind of like for a lot of smaller code bases. Some things just seem universally good because the consequences are so negligible, it just doesn't matter. A code base like Jira is not a carpool. It's a railway network. So diverting an entire railway network, whether it's changing the stopping patterns or building a station for one person who maybe should just buy an umbrella and a backpack, maybe not the best idea. In the real world, if you were to do something like this and have to consider these decisions, there would be a lot of different things you need to factor. First of all, the consequences, which are exactly the same dimensions, but just with that higher scale, a lot more impactful, right? Sydney Rail claims 1.3 upset customers every single day. Changing the stopping patterns for all those people, a lot different than 4 people in a car once a day, right? So again, the considerations, quite vast, all the things you need to do before we even got into making that change. Now, what you might be saying is, God damn, working in corporate sounds shit. No, that's not actually the point, because most people who are commuting on a railway aren't the ones actually designing the railway network, right? You don't get to get on the train and go, you know what, we're going to stop here and here and skip them. I don't really care about them. You're the people just riding the rails. And so when you're in a big company, it's the same kind of thing. We want to make sure whenever anyone is actually proposing to change the railway system in whatever way it might be, there is friction. Because unfortunately, the things that mess everything up are a lot less innocuous than building a whole station. They could actually even be just writing a function in the wrong place if you're unlucky. So we want to make sure that that actually matches the impact, so that these decisions are considered. If you're going to make your life a little bit easier, but ruin things for all those 600 devs, is it actually worth it? Just doing the right thing, building your features, slinging code should be really, really straightforward. And so that's the mission we try to follow. So that's where we're coming from when we get into these patterns. But what about the patterns themselves? What are these habits? Well, I'm going to start swinging. Don't repeat yourself is probably the second thing any developer ever learns. You learn what a variable is, then you learn what a function is, and you're told it is great because you don't have to duplicate lines of code. And that shit like seeps into our bones. Devs will walk across hot coals to not duplicate a line of code. And I'm not coming after dry, please don't lynch me. Again, this is a shades of gray talk, but there are consequences. Some of these are just bad abstractions. I'm not going to pick on those today. What I am going to pick on is no matter how nicely you write your abstraction, you have now connected 2 parts of your code base that didn't necessarily need to talk. Why does this matter? Well, let's say you're building a feature and you're working on your little feature down the bottom there. I should have put it in the middle, but I didn't. Generally, most tools that optimize code bases can deal on file-to-file relationships like TypeScript with references, or even some of the fax map stuff Shrey was talking about, at worst packages. Can't do execution paths normally. So that means at best we can optimize the stuff directly upstream and downstream with that change. You need that for your type check, for your linting, for your testing, all that kind of stuff. But if you happen to reach out to your feature to some random util just because you didn't want to repeat a couple lines of code or a constant, suddenly you have to deal with its stuff and then that stuff, and so on it goes until you now have to deal with the whole code base. If your code base is 100,000 lines of code, doesn't matter at all. When it is 14 million lines of code, that starts to matter quite a bit. And so these are the kind of things that we need to slowly then tease apart these connections through the code base. And sometimes that means the trade-off of just duplicating a couple lines of code is actually worth it. Shrey mentioned Thunderstone earlier. The key measure that we had for that was downstream files per commit. So for any change that we released, how many files were just downstream of that? Not even upstream, just downstream. This is the improvements we've made since Jan, which is fantastic. But as you can see, our P50 and our P90 used to be exactly the same. So whether you were making the median change in our code base, which is what, like 5, 10 files, you were dealing with 140,000 files. If you were making the worst case change in our code base, you were dealing with 140,000 files. That's not great. That's really, really slow. And so even just making this improvement, where now our P50 is 37,000 files, which is still shit, but we're getting there, we saw some pretty big impacts. For instance, the time a dev had to wait to get their very first green build on a PR used to be north of 30 hours for our P90 change. It's now halved. It's down to just above 15, which again, still really bad, but on 12,000, 1,200 PRs a week, that's 120 PRs a week now that we have saved 15 hours on. So instead of dry, if it's really simple code and you're working in these big code bases, we encourage our devs, sometimes it's okay to duplicate it, especially constants or few line utils. And if you are going to use them, if you are going to duplicate, you can also often find other ways to kind of achieve what you're looking for. If you want to make sure that every single date time in your code base is formatted the same way, you can use a function and route everything to it, or you might even be able to use a linting tool. If you want to guarantee that those two types are exactly the same, the contract doesn't break with TypeScript, duck typing, you don't actually have to reference the same type object to still get that build time safety. And if you are going to reuse code, do it when you actually need to. A lot of our devs will proactively go, someone might need this someday. They're asking me, they're demanding of me. So they'll go and put it off in case. What that often means, though, is you start building out utils, shared, common, which become these massive dumping grounds that every single part of your code needs to reach into, and now you've created a massive bottleneck, often for no reason at all. Okay, sometimes people see this and they go, well, is it just monorepos? Is it just the 14 million lines of code? If you had a nice microrepo, wouldn't this solve everything? Not always. Monorepos, especially in big companies, give you a lot of power. They allow to speed up a lot of things. So instead, what you're more thinking about is like the idea of a virtual microrepo inside your code base. It allows you to be a lot more flexible, and that means building tooling and rules to control what talks to what and where, which again was some of the stuff that Shrey was talking about earlier. I can go into this more, but I don't really have too much time. Okay, next, reducing boilerplate. For people who mostly write code for a living, we really hate writing code. So we will go through almost anything to get rid of it. Again, sometimes this is really good, right? It's good to be able to focus on just the logic that matters and get rid of all the cruft around it and all the risk of something going wrong. However, sometimes it makes things a lot more difficult, especially baking in assumptions in a big repo. Again, we say people often defensively put their code somewhere shared. They do that because this kind of stuff makes it way harder to share code later. The classic example is, I don't want to pass all those props into my component, so I'll create a hook that'll reach up into somewhere magic and do whatever the hell I feel like it. That now becomes way harder to test and way harder to extract it and share it with somebody else later when it's actually needed. Instead of sharing something proactively, just make it easier to share it when you need it. We've seen plenty of situations where there's like multi-month-long projects to go and rip a component out that already existed so other people can use it. But the other thing that's really important in a big repo with lots of people working in it all the time is it masks complexity, and people might not understand this. For instance, in our backend, the Jira issue bean, I know Java, gross, has getters and setters that used to directly call database. Some people didn't know this, so they would put those operations inside loops and just completely spam the database. In the front end, a really good example of this is playing a game that a lot of our performance champions like to play, which we call Guess the Costs. It's very simple. You look at this code with these three hooks, and you tell me which one of these is the problem. You guessed use org ID, congratulations, you get a cookie. It has a dependency chain of 100,000 files. Now, earlier I said this is really bad for all of our developer tooling. That is true. The people who pointed this one out were our performance champions, as in customer performance. Because think about all the processing that needs to go through for our customers before they even get their org ID, which we're probably not rendering on the screen. We're probably fetching something else instead. If instead you had chucked that in a relay query, or better yet, the thing you needed in a relay query, none of that would happen for any of our devs. And our tests would have been faster. Fantastic. So sometimes you just got to write the boilerplate in these bigger repos. Sometimes being a bit more verbose is the price we pay. But often as well, you see lots of boilerplate in situations where there's some sort of concept in your domain model that you have failed to capture. And so you're compensating for that lack of explicitness and that lack of that model with all sorts of config and generators and all sorts of stuff. So often instead, it's actually better to just do a redesign of your code and model that code out a bit better rather than use generators and magic and all sorts of other nonsense. Okay, now I'm going to go after the scout rule. Now, most devs don't actually clean things up very properly. They all follow the Sherry Bobbins rule of tidying up, which is I'm going to take this messy code, I'm going to take chunks out of it, I'm going to put it in a function, put that in a file, put that in a directory. All the code's still there, but now it's hidden and stuffed away and no one can see it. Progressive disclosure is a good thing. It can make it a lot easier to comprehend your code. I'm not going to disagree with that. But it can also cause a lot of challenges, often because many people have their own assumptions about what makes sense and how to organize all of that. It also can introduce our old friend coupling again, because often you end up creating dumping grounds for all those little pieces of code you wanted to hide. But for these big repos, another really big problem is it makes it way harder for our tools to work through our code base. We have situations where devs want to have their test file next to their component. or inside a test directory, or inside a test directory at the root of their package, or they want to have all of their integration tests and unit tests and visual regression tests all together or separate. Now our tools need to handle every single one of those cases. When you have to build code or test code or lint code, the first step of that is finding the code. And at scale, that can actually take a really long time. What we found is generally it's better to structure your code for the benefit of your tools rather than your humans, because often human optimization comes from consistency. We're really, really good at pattern recognition. So keeping everything the same, meat space is happy, keeping things structured, optimized for the regexes and globs and stuff you have to write, keeps the computers happy. So that's what I'm kind of saying there. Consistency and standards make a really big deal. Meaningful and unique names also matter a lot. You can start building all sorts of optimizations. Atlassian as a company, we actually have our own internal bundler. That means we could bake assumptions into our bundler to skip all sorts of processing and all sorts of things that things like Webpack and Parcel and RSpec have to compute. We can just skip that stuff if we know things are completely unique. Same with any of our tools. That can allow some really powerful stuff, like some of the dead code deletion stuff Shrey was talking about. Only works because we know this mock, this example, this test, all of the only usages of this code because of the naming conventions. Now APIs. This is a big qualifier. I don't mean REST APIs, public APIs, GraphQL, APIs for your library. What I mean is in big repos, what devs tend to do is think of their component or their package as their little fiefdom and their little world, and the rest of the code base is the vast wasteland full of terrible devs who don't know what they're doing. We're the good ones. And again, that means you kind of build this barrier. Often that's really good, clearly explains what your code is doing and what it's not doing. But over time, it atrophies, almost always, because it becomes really hard to change these sorts of things. For instance, if I want to update my API, I need to change all of the call sites across the code base. That might end up being hundreds of teams I need to contact for reviews and approvals. It might mean massive risk of merge conflicts where I can never land my change. So people generally just jam in configs, jam in options, and that then becomes all this bloat. That becomes, again, another bottleneck in the graph. An example, as was mentioned earlier, is barrel files. I think most of you probably know what a barrel file is. Index file at the top of your package. You nicely declare all the things that you have. People love this. It means you can have, this is my public stuff, this is my private stuff. It cleans up the imports so they're easier to work with. Except when they end up turning into 100, 200 line files. Or people start exporting something from one barrel file to export it in their barrel file, because my component also technically exposes this as part of my API. It becomes impossible to find anything. You get all sorts of crazy bottlenecks. When we debarreled our code base, we saw insane improvements. The one I'll pick on is 88% fewer unit tests run in a typical build. So think about that. When you built your code in CI, only 12% of the tests run were even remotely relevant to your change. I was so successful, actually, we're now pulling them out of platform. We're pulling out other products and stuff as well. So in a big repo, your code isn't yours. They're in the same repo as you. It's not hidden. It's not private. If they want it, they'll reach in. They'll take it. So instead, think of your code as actually composable. Don't config. Don't build out all these magical barriers. Instead, build your thing out of meaningful building blocks. Anything underneath that, assume someone will access and treat as its own thing. If you really want to protect it, just embed it. That's what I was kind of talking about earlier with tidying up, with dry. We've seen situations where we went through and we inlined code that was only ever used once. In one of those situations, there was this bunch of code. It was 3 different packages. Each package had like 5 to 10 files, a bunch of different config, all sorts of stuff. And every time we inlined something, we could remove the generics, we could remove the function signatures, and it got simpler and simpler and simpler because it was only used once. Turned into one 35-line file. You tell me which one's easier to maintain in that instance. Okay, test coverage. Now I have to preface here, tests are good. Please write tests. Don't anyone go, that guy from Atlassian said tests suck. No, 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 that's not what I mean. What I mean is tests aren't free. At a big code base and a big repo, that can have a really different impact in what you actually decide to cover and not cover. For instance, the more tests you have, the higher chance you have flake, the higher chance you have failures in your build. It becomes really difficult to land something. It's also most of what we end up doing in our CI in a big company. It's relatively quick to build the code base, much, much harder to actually test every single permutation. And also, if you go too overboard, you start getting a false sense of security because people start working around the barriers you've put in place. Uh, I'm going to pick on visual regression testing. For anyone who doesn't know, that's just snapshot testing. You take a snapshot of a component, compare the old to the new. In master for us, it was failing between 5 to 6% of the time. Quite a lot of flake failed about 15% of the time in branches. Most of the time that was fixed by someone just regenerating the snapshot and going, yeah, I meant to change that. It was also one of the most expensive things we had. This is our build minutes. And every time it got crazy big, we delete a whole bunch of redundant ones, but these aren't useful. And then we just keep growing and growing and growing again. But also wasn't protecting shit. We had a team, one of our design system teams, they rolled out a topography change. It became so difficult for them to update all the screenshots. There was like thousands of screenshots across all different code base areas that they just decided to roll it out to prod and flag it off in the tests. And it sat that way for 10 months with our VR tests not actually testing prod state. And then they put together a proposal to progressively roll it out across the test suite. Now, I don't want to like dig on them too much. It's more our fault that they had to jump through these many hoops. They have to ship stuff. They have deadlines to meet. It was impossible for them to do the right thing. This was them trying to at least do something about the right thing. So tests can go crazy wrong if you do them incorrectly, especially people see them as low value. When I started talking to people about that problem, everyone had a different opinion of what VR tests were for. Some are like they test layouts. Some people test like micro components. So how can anyone agree? There's just going to be more and more for everything. The testing pyramid is a pyramid for a reason. If you have an end-to-end test, don't test every permutation, even integration test. Think about what the unique value add of that testing layer is, and only exercise that. Trust the lower layers to exercise everything else. If you're going to propose a new layer or a new type of testing, like for instance, we've got tons of feature flags, people are talking about on-off testing for all the flag states. Make sure, again, the value is really clearly realized. Is it actually that you just want to make sure that all the off states work, for instance? Maybe that's actually the main value, so you can turn them off in an instant. And if you are going to drive up tests, because again, tests are good, coverage itself is a really bad metric to chase. Look for test quality. Look for number of bugs caught. There's lots of ways to do that. There's lots of tools out there. Mutation testing is a great way to see your bug catch rate. That's the kind of number you should drive up instead of coverage. Same for process. Often automating process, again, same kind of problem space. It makes things way easier because things are automated for you, right? Often when teams want to automate process in a big repo, they want to automate just their process. So it's their check. When you touch their code, you'll get their bullshit. But beyond that, often, please, did you remember to read this page or do this checklist? Promise me you did this thing. It's actually not solving work for people. It is generating more work for those people. So again, time and money, false sense of security come up, but also it encourages people to do lots of crazy workarounds. Didn't take me too long looking through our code base and our PRs to find one with 109 PR tasks automatically added to that PR. Do you think that dev went through and diligently followed every single one of those tasks, read every single page, reached out to every single team? Absolutely not. They just landed it. In fact, I know of some devs who have monkey patched in send it buttons to Bitbucket. They just go through, mark all the tasks as done, land the PR, she's good. First, I was horrified about this, and then it made me think of exactly the same VR testing scenario. We kind of made this a tax on our own developers. They have to work around it. So again, standards are your blessed thing here. If you have something for just your team and you can't be bothered to make it the thing for everybody, probably a good litmus test that that thing is not that useful. And if you are going to put in checks, make sure that they're explicit, that you can actually codify what they are. They're not just informational warnings, so people will ignore them. If you can do that, you can also normally automatically fix them. It's just as important to tell somebody how to solve their problem and what to do as to stop them from doing the wrong thing. Otherwise, they'll reach out to your team and ask you, how do I ignore this? How do I skip this? We've learned that lesson the hard way. Last one, coming after everybody's fun. In a big repo, trying out a new tech can actually be really consequential. Again, good, you can skip all the red tape, you can validate the impact, you can test it at scale and make sure it works. The bad is it can become really hard to get that thing out later. Often there's lots of companies like Amazon talk about two-way doors. You can go through a door and you can come back out of it again. That's true with putting new tech in, except normally someone like piles a mound of sand behind the door after you do it and it becomes a nightmare to open it back up again. And often as well, us as devs are really bad at deciding what is actually worth adding to the code base and what isn't. I see a lot of these kind of conversations. It's the industry trend, it's new and it's sexy. Yeah, until people move over and fix something else. Oh, we've got this bug that's impossible to solve any other way. Yes, it will solve that. It will also have its own bullshit, trust me. But it's new, it's shiny, it's so much easier to work with. It's not the same as all those old crusty libraries that were new and shiny when we put them in. And if we build that thing, everyone in the team will want to adopt it. They'll race for it. I guarantee you, when you've got thousands of devs, absolutely no. They've got other shit to do. So what we end up seeing is a stratification of technologies through our code base. At one point, Jira had like 8 state management libraries because no one could bother to clean them up. They just kept putting new bullshit in. Here's an example. We moved from Cypress to Playwright, 2 different integration testing frameworks. It was the right decision. There was lots of reasons we thought through, but one of the arguments made falls into this fallacy. We said, there's this particular timeout that exists in Cypress. Happens all the time, causes all sorts of flake on master. Because of how Playwright works, it's impossible for that to happen again. Therefore, there'll be no flakes with Playwright. Well, no, it's still one of our most flaky things, and we deal with that bullshit all the time. If that was the only justification we made, and often that's what happens, it would have been entirely the wrong call. Thankfully, cooler heads prevailed. We analyzed it a bit more deeply. So make sure you're making a fair comparison. And if you are going to put something in a big code base, make sure you get it all the way to 100%. If you say, I'm going to put it in and then it'll grow over time, you've introduced bullshit and legacy that everyone will hate you for forever. So those are the 7 things, the 7 lists of no fun. But don't think of these as like, oh man, working in a big code base is really depressing. I can't do all of my favorite things. Remember that there's a North Star we're shooting for here. I think most devs would trade off duplicating a couple lines of code or having to read a bit more boilerplate for lightning fast builds, 5-minute builds instead of 2-hour builds, things like that. So when you kind of follow these practices and you think of your code as a community health thing, you understand the underpinnings of that code, the implications of your decisions, you end up with the fastest damn train network out there. Thanks.
All right, that was awesome. Do we have any questions for Coby? I think you covered everything. Oh, hang on. Yep.
Some things that's been mentioned before, but you talked about permutation testing, and I'm not too sure what that is. Could you explain a bit what
penetration end-to-end or penetration?
No, permutation.
Oh, mutation testing. Yeah, sure. Mutation testing is a wonderful tool. It came from a lot of our friends in the Java land where it's a lot easier to mess with bytecode. But now there are tools that you can look at within JavaScript as well. Striker is a great tool for it. The idea of mutation testing is you take your tests, you run them, then you go and mutate the code base. So you go and modify some of the instructions. You delete conditions, you replace returns, you do early exits, all that kind of stuff, and just mess with the whole code base. Then you run your test again and see if it caught it. If it didn't, then that is an entire change that someone could have shipped to prod that broke the experience for customers and it didn't otherwise. So you run these over your code base at scale and it gives you an indication of how thorough were your tests actually. Not just did I hit that line of code, but did I actually catch something that was a meaningful change? Really, really powerful tool. Encourage you all to look into it. That's your question? Cool. Any more?
Because you mentioned try not to chase shiny new tools, but you also said yo to Java earlier. Wouldn't it make more sense to be liking Java more because it's kind of slower moving compared to the front end JavaScript land?
It's a really good question. If we didn't chase the new hotness at some point, we would still be writing, JSX or JSP or soy templates or something like that. At some point, there is a new technology that is just objectively better than what came before it, and you need to analyze that. So when I caution people from just chasing the new shiny in a big code base like ours, I'm not saying don't ever do it. I'm saying let's make sure we reason it correctly. What's the cost of moving on to this new thing? What does it give us? Does it give us just as much as if we invested at the same time in the existing tech and made it better? Or is it actually, no, this is a big change, it will make a big difference and it will solve a real problem? So yeah, it really does depend on the change and whether it's actually worth it or not.
Has Java burned you that hard that you're disgusted by it?
Personally, no. I came from a Java background. I mean, I prefer Kotlin over Java if I could be pedantic, but no, Atlassian has been burnt by new technologies in the past. We got really burnt by Scala at one point. The point became a dirty word within the company for years. Even the founders of the company were no, Scala. So yes, but that was misusing a technology. That was chasing something without really understanding why it was. I think all those technologies solve different problems and can be employed in different situations. It just depends on what it is you're trying to build.
Yeah.
Yeah, so all of our backend, well, large chunks of our backend are built in Java or JVM languages, for instance. So it's about the right tool for the right job. Cool. Any more questions?
So basically, we're talking about bringing in some order into insanely large code base, right? So could you please share your overall strategy for approaching this problem? I mean, we touched in the previous speaker the topic of kind of like using AI for these kind of things, right? You were sharing your insights towards like golden rules having exceptions, like we always do, right? So what's your overall strategy towards rearranging and let's say this word refactoring 14 million lines of code,
Yeah.
and how much of an effort you're putting into every branch of this strategy? Thank you.
Yeah, so the first thing you got to do is develop a drinking problem. That's like the absolute first step. Actually, the real first step in a very big company is trying to teach very senior people who know everything about engineering that basic code base habits are actually important. Beyond that, then, this is actually a whole talk in of itself, which I've given in the past. But the thing I'll say is, it's very easy to want to improve every single problem. Often when people pitch a new architecture, a new design, they want to rebuild the entire world, solve every problem top to scratch. I'm going to take this old dead code here and move it over to this new shiny system there. In a big repo, what that ends up being is you have a split in your code and then another split in your code. For instance, in Confluence, I think that they've got two top-level directories, Confluence and Confluence Next. And Confluence Next is like 6 years old. So this kind of stuff needs to be done progressively, and it needs to be done with a prioritized way. That's, for instance, why when we're trying to say fix Jira, we're just starting with the code structure and how the code interrelates. We're not talking about our state management libraries, which need to be fixed. We're not talking about testing habits. We're not talking about anything else. One problem at a time, the biggest problem at a time. Then ideally, you want to do that deterministically. That's kind of one of the cruxes of what Shrey was talking about, which is if you change this stuff with AI, you can cause incidents because AI makes change, like it makes mistakes. Use those tools to build something that's repeatable, and then you roll that out at scale. You try to build tooling that you can run across the entire code base that's performant and do one big change in one big bang as much as possible. So for instance, that Playwright to Cypress conversion, that one we did do with AI. It took us about 3 months with a team of devs. Just using AI massively accelerated that. The previous version, when we moved from Enzyme to RTL, took like 4 years, wasn't it, Shrey? So doing it manually, big acceleration. But now we can do even larger accelerations of that statically with way more confidence without causing any issues or regressions. So it's about using the right tool for the right job. Answer your question? Yeah. Cool. Yeah.
So I'm kind of going on that same thread there. So you've got these massive interdependencies between all your modules, and it sounds to me like, I mean, I've been in the software industry for 40 years. I can tell you that it sounds like there's a tool problem with that. You've kind of influenced, or people are influenced by the ability to do those things, and so they do them, right? So it's like C and C++, you know, you've got the foot gun. Well, here you've got a massive foot gun, which you've basically adopted a methodology which has allowed that kind of thing to happen. So have you thought about, you know, putting some more guardrails or using different paradigms to make it so that people will avoid making these kinds of problems in the future?
Yeah, you've hit the nail on the head. 100%. That is the entire problem, is if someone is allowed to do that thing, they will do that thing, no matter how terrible it is. If it's a green build, looks good to me, ship it. And so that is the consequence, right? We've got these frameworks and tools and ways of building things. You know, React provides context, React provides hooks. Suddenly you can do all these crazy magic things and so on and so forth with all the different technologies. So the entire thing that we're doing around fixing our code is exactly that. There's no point in cleaning it up once, because someone will just undo it again. Everything we need to do needs to be done statically, and it needs to be enforced, and it needs to be regressions. This talk came from us putting in rules in the code base to stop people from doing some of these things when we determined it was bad and people got upset and wanted to work around it. But it doesn't work to just tell a bunch of people don't do this, especially in a big repo. When I was thinking earlier, 2,000 devs in a 6-month period. You can't get 2,000 devs to really understand that at any given point in time. You need to prevent them and stop them. That then leads into the problem of how do you educate them? How do you stop them in place and then tell them the right thing to do in that moment and make sure that they've got that pleasant journey? But yes, it's all about guardrails. Yeah.
Awesome. All right, let's give Coby another big round of applause.